Have you ever wondered why, despite all the hype, AI is still not as fast and efficient as we'd like it to be? Well, let's delve into that question, shall we? When we think of AI, we often picture futuristic robots or complex algorithms, but the reality is far more grounded. The truth is, even the most advanced artificial intelligence systems we have today are bound by the limitations of their hardware. You see, the vast majority of AI relies on graphics cards for crunching numbers. While these cards are great for parallel processing, they're not exactly energy efficient. And when it comes to speed and efficiency, they can't hold a candle to the real-life neural networks found in biological brains. Now let's talk about computer chips. These tiny powerhouses are the backbone of our digital world. But they too have their shortcomings. The architecture of these chips creates a bottleneck effect where data has to be shuffled back and forth between separate calculation and memory components. This two-step dance slows things down and throttles efficiency. But what if there was a different way? A way to process data that was faster, more efficient, and more in line with how our own brains work. Enter neuromorphic computing, a pioneering technique that aims to mimic the neural mechanisms of the brain. Instead of static computations, neuromorphic computing utilizes dynamic electrical spikes for communication, much like biological neurons. This approach, known as spiking neural networks, incorporates time as a key element, allowing for rapid, efficient data processing. By harnessing the power of these spiking neural networks, we can unlock AI capabilities far beyond what today's hardware allows. We're talking about handling complex tasks exponentially faster, all while using far fewer neural connections. Not to mention the huge energy savings that come with event-based spike processing. This is where DeepSouth AI steps in, offering a new approach to AI technology. By combining specialized algorithms with this neuromorphic approach, DeepSouth AI is leading the charge into a new era of computing. And the possibilities, well, they're as limitless as our imaginations. DeepSouth AI is pioneering a new era in AI technology with its unique spike-based approach. This innovative method is inspired by the human brain's complex network of neurons, which communicate using electrical spikes to process and transmit information rapidly. Known as spiking neural networks, these systems bring a dynamic element to AI that elevates it far beyond the capabilities of traditional static computation models. The genius of spiking neural networks lies in their ability to utilize time as a crucial component of processing. Instead of treating data as a static entity, these networks encode information in the form of spikes that occur over time. This dynamic encoding process allows the networks to process complex tasks with an efficiency that is exponentially faster than conventional AI models. Moreover, spiking neural networks achieve this speed while using fewer neural connections, leading to significant energy savings. DeepSouth AI has harnessed the power of these spiking neural networks to create an AI system that is not only faster and more efficient, but also highly adaptable. The company's unique spike-based algorithms are the driving force behind this adaptability, allowing the system to scale up and handle a wide range of tasks with unparalleled performance. Central to DeepSouth AI's approach is the integration of these algorithms into its AI hardware. This integration enables the system to convert static data into dynamic spike sequences, which are then processed using advanced techniques such as spike timing learning, reservoir computing, and converted analog networks. The result is an AI system that can process data at astonishing speeds and with remarkable efficiency. With its innovative, dynamic approach, DeepSouth AI is pushing the boundaries of what AI can achieve. By mimicking the human brain's neural mechanisms, the company is ushering in a new era of AI technology that promises to revolutionize a wide range of industries. From healthcare to cybersecurity, the potential applications for DeepSouth AI's technology are vast and exciting. This is just the beginning of what promises to be a thrilling journey into the future of AI. At the heart of DeepSouth AI's innovation is its neuromorphic architecture. This architecture is a multi-layered marvel that's designed to mimic the dynamic behavior of neural networks in the human brain. It is here where the magic happens, transforming the way AI processes data. Let's begin with the unique input layers. You see, in conventional AI systems, data is static. It doesn't change over time. But the brain doesn't work that way. It constantly processes dynamic information. DeepSouth AI's input layers emulate this by converting static data into dynamic spike sequences. Imagine a quiet, still pond suddenly disturbed by a stone. The ripples that radiate from the point of impact? Those are akin to the spike sequences that this system generates from static data. Next, we have the network modules. These aren't your run-of-the-mill components. They're sophisticated mechanisms designed to process these dynamic spike sequences. The modules utilize techniques such as spike timing learning, reservoir computing, and converted analog networks. Spike timing learning, as the name suggests, is all about the timing of the spikes. It's a method that adjusts the strength of the connections between neurons based on the timing of their spikes. Reservoir computing, on the other hand, is a fascinating concept where a recurrent neural network is used as a reservoir of dynamic features. The spike sequences are fed into this reservoir, which then processes the information in a manner similar to how our brains handle stimuli. Converted analog networks add another layer of complexity. They take the spike sequences and convert them into a format that's easier for the system to understand and analyze. Lastly, we have the linear decoding systems. These are the interpreters, the translators. They analyze the spike signals processed by the network modules and provide outputs. It's like deciphering a secret code, but instead of letters and numbers, it's spikes and sequences. This neuromorphic framework is what gives DeepSouth AI's technology its astonishing speed and efficiency. It's a beautiful harmony of layers and modules working together to mimic the most complex organ in the human body, all to make AI more powerful, more efficient, and more revolutionary than ever before. The potential of DeepSouth AI's technology is immense and far-reaching. This isn't just about making machines smarter or faster. This is about transforming industries from healthcare to cybersecurity and even space exploration. Imagine rapid clinical analytics in healthcare, able to process and analyze vast amounts of data in the blink of an eye, improving diagnosis and treatment plans. Or consider lightning-quick automated cyber defense systems, capable of detecting and responding to threats faster than ever before. DeepSouth AI's adaptive solutions could even accelerate space travel and exoplanet discoveries by processing and analyzing the colossal data sets involved in such missions far more efficiently than current methods. The potential revolutionary impacts of DeepSouth AI's technology are not limited to these sectors. Virtually every industry stands to benefit from the order of magnitude improvements promised by their neuromorphic architecture. As we look to the future, it's clear that DeepSouth AI's technology could dictate the pace of progress across sectors for decades to come.